Okay, again, why are we doing this? Okay, well, linear equation, I'm going to define to be an equation can be written y equals mx plus b. Okay? And actually, I should call it a linear function. My terminology isn't great here, but we'll proceed anyway. Okay, so can we put this in the form y equals mx plus b? Well, we notice that this is a y equals something and there's no y over here, right? So we solve the equation. If this is the equation, is this linear? We solve the equation for y and see if it ends up in a y equals mx plus b form. How do we solve this equation? Now this is algebraically fairly straightforward. We should be to the point from what we've seen where we can easily solve this, but I'm noticing that we probably as a class aren't. Leaves me a little bit of a quandary because normally that's something I'd address in the MCR, but the MCR students appear to be in pretty good shape with this sort of thing. But we'll probably talk about it Thursday anyway, or yeah, Thursday, just to make sure. Okay, well anyhow, what do we, so we have 4x minus 7 over 6y minus 4 equals 9x. Now I hope, because I've said it many times and done it many times, that you understand that whenever you have a denominator in an equation, you multiply both sides by that denominator, or if there's more than one denominator, by some common denominator. Now this is something that I would fully expect everybody to have locked in by this point, and if you haven't, please, for your own sake, lock it in now because you have to know how to do this, okay? Hey, y'all are doing pretty well with adding and subtracting, multiplying fractions and stuff, so, you know, that's at least as hard as this. So I know you can do this. Just make sure you have it on your radar screen and remember that this is what you have to do, okay? So we multiply both sides by the denominator. That's 6y minus 4. And we put parentheses around this thing. One error that I've seen a lot of is people not putting parentheses around something they're multiplying by both sides of an equation, so they end up multiplying this thing by only one little part of the equation, not the whole thing. Okay? And we really can't do that. So that's then times 4x minus 7 over 6y minus 4. On this side, we do 6y minus 4 multiplied by 9x. Notice if you didn't have the parentheses here, you wouldn't necessarily remember to use the distributive law in multiplying this, which you really have to do because you have to be multiplying by this whole quantity. And then you might just multiply the negative 4 by the 9x, okay? And not multiply the 6y by the 9x. Or do something else. If you don't have the parentheses there, you're in serious danger zone of totally messing up the solution, okay? Very important to have that parentheses there. Well, 6y over 4 is going to be divided by this 6y over 4, and that's going to give us just a 1 multiplied by the 4x minus 7. We've done this a number of times, so I'm not going to write out every step of it because we need to start using the algebra that we've developed rather than repeating all the details. Anyhow, that will be 6y minus 4 times 9x. Okay? Now what's the next step in solving this for y? What do we want to do next?
You multiply 9x times 6y minus 4.
We could. Okay? We could do that, but we're really trying to isolate y. There's no point in having a 9x attached to our y. Okay, so the distributive law would be okay, but once we did that, we'd find that we didn't really want to. I'm going to divide both sides by the 9x. Okay? Now, go ahead and do this. I do recommend that you go ahead and do this by multiplying this out and following the steps that you would follow after doing that. Okay? So you see that you get the same thing, and if you don't get the same thing, then you want to think a little more carefully about how you did the algebra. Anyhow, so I'm going to divide both sides by 9x. and I get this. Now, I do have to be a little bit careful here, because when you divide by something, that something can't be 0, because division by 0 is undefined for reasons that I hope we understand, okay? So, we've got to put a little qualifier here. We want to get used to doing this. We haven't done this in the past. But you have to say that 9x can't be 0, so x can't be 0, right? The only way 9x is going to be 0 is if x equals 0, and if x is 0, so is 9x. Okay? As long as x isn't 0, you can divide, but if x is 0, you can't. So you get 4x minus 7 over 9x equals 6y minus 4.
Because basically the 9x over 9x is 1. And this one's
Say that again. I didn't get.
Like how you usually do, like 6y minus 4 over top of 1 times 9x over top of 9x.
Yeah, but you're not going to multiply these. You're trying to solve for y. So really all you have to do is add 4 to both sides and then divide through by 6, and you're going to get y.
Okay.
Okay? So you're going to get 4x minus 7 over 9x plus 4 equals 6y minus 4 plus 4. Okay? I'm adding 4 to both sides, and I really prefer not to see you write a 4 and a 4 here and then think you're adding it to both sides, because I see a lot of mistakes in doing that. It's okay to do that off to the side and check to see if you get the same thing when you do this, but I really would rather see both sides written out with a plus 4 and a plus 4. Okay? Because that's really what you're doing. The other way is not absolutely wrong, but I'm not going to be real forgiving of mistakes that happen if you do it that way, because of that. Okay, anyhow, what we get then is 4x minus 7 over 9x plus 4 equals 6y. Okay? Then we have to add these fractions. So I'm going to put a couple of dots here. I'm not going to do that, but we multiply the 4 by 9x over 9x. And we get 36x over 9x that we add to this. And we end up with 40x minus 7 over 9x, just by adding, like this, plus the 4 over 1, and doing the things that I think people are pretty good with. And that's equal to 6y, okay? Then we divide both sides by 6. Put a couple of dots here, because we don't want to. And we're going to get y equals 40x minus 7 over 54x.
Where'd you get the 40?
Huh?
Where'd you get the 40x?
In these dots, common denominator, add them, and that's what you're going to get. You got this plus this. You got to express this as 36x over 9x. Okay? And then you're going to add the 36x with 4x to get 40x. I'm not going to take time to do that. We've done this. If you're making mistakes in this, we'll address it later. But we can't learn the pre-calculus if we have to keep going over the algebra that we've already gone over, okay? So work that out. If you're not getting it, I'll give you comments. We'll address it, but not in class. In any case, the point is, if we solve this for y, we go through steps much like this, and we get this, okay? Is this in the form y equals mx plus b? Can it be put into the form y equals mx plus b? Can't be. Okay? Because, okay, well, this is 40x over 54x minus 7 over 54x, right? So finally, okay, 40x over 54x reduces to 20 over 27. Minus 7 over 54x. I'm going to write that up here. Y equals 20 over 27 minus 7 over 54x. Okay, is that in this form? Well, no, it's got to be a multiple of x, not a multiple of 1 over x, right? Okay?
I think we kind of lost a lot of people when we got to 40x minus 7.
I'm sorry?
You lost a lot of people with
Yeah.
40x minus 7.
Well, you do what you do with common denominators, and that's what you get. Okay, so I want you to fill in those spaces there, okay, those blanks. And I understand that, I understand that in these dots, some people are going to be lost, but this just follows from procedures that we've learned, and we can't take time to do the algebra. We'll take some time in the MCR and do this, so there'll be some videos on it, probably Thursday, okay? Okay, so this isn't in the form y equals mx. Okay? That's it. Now again, this algebra is reasonably challenging, but you should be in shape where you can do it. If you can add fractional expressions like x plus 5 over x minus 8 to x minus 3 over x plus 12, which you can do, none of these steps are too awful difficult. So see if you can fill in the blanks, and if you can't, bring it to the MCR class. I'll see it in your homework. We'll address it probably more through videos and in the MCR than in class. Okay? Because this is simply information that you're supposed to come into this class with. Not that you're evil for not doing that if you didn't, because most people don't have it when they come into this class, but we can't teach the pre-calculus class when we have to go back and teach early algebra 2. Okay? But we'll address it. Okay? So I have to leave some dots in here, ask you to fill them in. I think most of you can fill these dots in if you work on it. So please make yourself a note and try to do that.